In the next section, we're going to complete our study of imaginary numbers. Now, a complex number you learned about yesterday. A complex number is something like 2 plus 3i. Okay? It's where it has a constant and an imaginary with it. Now, a lot of people think that complex numbers can't be pure imaginary numbers. But for all things essential, you could be adding 0 to it. For example, if you just had 4i, you could say that's 4i plus 0. Okay. Let's go ahead and just do some review from yesterday. Problem 1. How do you write the square root of negative 18 by using the imaginary unit I? Well, yesterday you learned you would take out an I to start with, and you would make that the positive. Now you have the square root of 18. So you're saying it's the imaginary root of 18. The next thing I hope you remember is always simplify your square root. 18 is made up of 9 and 2. The square root of 9 is 3. You have the imaginary root of 2 left over. Let's practice one more time. The square root of negative 12. You say that's the imaginary root of 12. Then you break 12 down into 4 and 3. You take the square root of 4 and you get 2i square roots of 3. We already talked about this idea of a complex number. A complex number is made up of a real part and an imaginary part. We have also talked about a pure imaginary number. And a pure imaginary number is when it's just made up of the imaginary part. The next part is new to you. It's how to graph these and how to find their distance. If I ever ask you, or a quiz or a test ever asks you to find the distance, that just means that you're finding the absolute value of your imaginary number. Okay, we have the complex plane. You guys are used to a x and y plane, right? You're used to what we call the coordinate plane. Okay? The coordinate plane is made up of x and y points. Well, the complex plane works just like the coordinate plane. Instead of having x and y points, you have a and b points, where a are the real numbers and b are the imaginary numbers. So let's take a look at this example over here. You see your real axis? It's like what you would imagine as your x-axis. You see the imaginary axis? It's what you would think of as your y-axis. So we have 3 minus 2i. All that means is that you go over 3 and down 2. All right, let's find that. Over 3, down 2 puts you right there. All right, there's their point. Now, if they wanted the absolute value of it, what you have to do is you square a, square b, and then take the square root. So in our example, you would do the square root of 3 squared plus b squared, and b is negative 2. You would then finish that out by doing the square root of 9 plus 4, and that is how they got the absolute value of 13. So this is called its distance. It's also called its absolute value. Let's try some ourselves. We have negative 5 and 3i. Give yourself a set of axes. Remember, it's no longer x and y, it's the real numbers and the imaginary. So we're going to go left 5, up 3. Make a dot. It says, what is the absolute value of this number? Well, that's asking about this line right here. In other words, it's its distance back to 0, 0. What is the absolute value? Okay, write this down. Absolute value is the square root of, well, let's square 5 right away. That's 25 plus, what's 3 squared? 9. Therefore, the absolute value is the square root of 34. Here's the graph. Here's the absolute value. Let's try it one more time in part B. Let's add a plus 0 in there for the real number. Now remember, this one's your real axis, this one's your imaginary axis. So the real number is 0. That means we move left and right 0. The 6i moves it up because the imaginary moves up and down. In order to find its distance, it's asking you to find this blue line right here. Its distance away from 0. Ready? Let's find its absolute value. So we take the square root of 6 squared is 36, plus 0 squared is 0. So that's the square root of 36. The answer is 6. Let's try this a couple more times. Get your graph on. Put a 1 in front of that I so you know what you're doing. This means to go to the right 5 and down 1. 1, 2, 3, 4, 5, 1. Here's the point. This is the distance. This is the absolute value they want you to find. So to find the absolute value, you do the square root of 5 squared is 25, plus 1 squared is 1. So the absolute value, or its distance, is 26. Try it again. This tells you to go left 3 and down 2. 1, 2, 3, 1, 2. Get your absolute value on there, the distance, and let's solve for the absolute value. Well, it's the square root of 3 squared is 9, 2 squared is 4. That equals the square root of 13 for its absolute value. Part C, the 1 wants us to go to the right, the 4 tells us to go up. Right 1, up 4. There's the point. Here's the absolute value, or the distance they want you to find. The absolute value is the square root of 1 squared is 1, 4 squared is 16, that's the square root of 17, which does not reduce. Let's review a little more from yesterday. What is the sum or difference? Remember, you just combine like terms. So 4 and negative 4 cancel out. Negative 3 and positive 3 cancel out. What's the sum? 0. Let's go to part B. Part B is subtraction. So we have to distribute our negative. So when we distribute our negative, we get a positive 2 and a minus 4i. That's a big mistake a lot of people make, is forgetting to distribute the negative. Now we can combine. 5 and 2 is 7. Negative 3 and negative 4 is negative 7i. You don't have to write plus a negative. You can just write minus 7i. Try it again. This is addition, so we don't need to distribute anything. 7 and negative 3 is a 4. Negative 2i and I is a minus 1i, or minus I. As we move on, you will notice that problem 4 is also review. Let's make a note of something, and this isn't multiplying, okay? We just did adding and subtracting, now we're doing multiply. Let's make a note of something, that you should never leave I squared, because I squared is equal to negative 1. Never leave I squared, make it a negative 1. Alright, let's see how that little hint's going to help us. Let's distribute 3i. So that's negative 15i, because 3 times negative 5 is negative 15. And 3 times 2 is positive 6 with I squared. But you never ever leave an I squared. You make that negative 15i minus 6. Now if you really wanted to be technical, I think usually we put the regular number first. It's not a big deal. Let's go ahead and distribute on part B. 4 times negative 1 is negative 4. 4 times minus 2 is negative 8i. 3i times negative 1 is minus 3i. And 3i times negative 2i is minus 6i squared. You will never leave an I squared. you simply make it a -1, which turns this into a +6. So now we will combine. -4 plus 6 is 2. -3 and -8 makes -11i. Let's try it one more time in part C. Distribute in. Here, 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 and here. Now if you remember this word from yesterday, you should memorize that this is a conjugate because it's plus and minus of the same thing. Let's do -6 times -6 is 36. -6 times -i is +6i. Positive I times -6 is -6i. And I times -i is -i squared. You'll never leave an I squared, so this changes to a +1. Now combine your like terms. 36 plus 1 is 37. The 6 i's cancel out. Let's try the got it. This one, there's just one side of distributing. 7 times 3 is 21. I times I is I squared. Never leave an I squared. That makes it a -21. In problem 5, I'm going to do problem 5, part A, and then we need to talk about how part A is different from part B. We did do this yesterday, but this is a point where a lot of people get stuck. You can never write this down. Never have I in denominator. It's like not simplifying it. So let's look at problem 5, part A. You see how this one's a monomial? We're going to handle that differently than part B, the one that's a binomial. Alright, in part A, when the I is part of a monomial, all you have to multiply by is what you want to get rid of, I over I. You want to get rid of the I, so multiply by I. We'll distribute in. Yes, we will distribute backwards. So 9 times I is 9i. I times 12i is 12i squared. We'll fix that I squared in a moment. On the bottom, I times 3i is 3i squared. We'll also fix that I squared. This becomes a -12 because it's I squared. So the top becomes -12 plus 9i. The bottom becomes a -3. One thing I hope you remember, and if you don't remember it, let me teach it to you. You should never have a negative on the bottom. So we're simply going to divide every single item by a negative, and that's going to turn into, and in fact, everything also divides by 3. So let's divide everything by a -3, because everything does divide by a -3. So -12 over -3 is a +4. 9 over a -3 is a -3i. So we reduced, and we have our final answer. Part B will be different because it's a binomial. When you have a binomial, you learned this yesterday, you must multiply by its conjugate. So we are going to multiply by 1 plus 4i on the top and bottom. Always change that sign. That's going to get rid of the I. On this one, it's going to require more work because you have to FOIL in the top. 2 times 1 is 2. 2 times 4i is 8i. 3i times 1 is plus 3i. 3i times 4i is plus 12i squared. That's the top. The bottom, you have to FOIL again. Unless you remember the shortcut, you're going to have to FOIL. 1 times 1 is 1. 1 times positive 4i is 4i. Negative 4i times 1 is negative 4i. Negative 4i times positive 4i is negative 16i squared. Let's combine our like terms on the top. Remembering that positive 12i squared becomes a -12. And on the bottom, remembering that minus 16i squared becomes a plus 16. On the top, when we combine our like terms, we get 2 minus 12 is negative 10. 8 plus 3 is 11i. Over Look how the 4's cancel out. Remember how we said the i's go away? That should always happen. 1 plus 16 is 17. At this point in time, nothing reduces. So we're done. You may notice in the book that their final answer might be separated like this. They might just put them each over 17. They're both the same answers.